Dear student, today we will discuss about the different types of modulation technique in the field of communication system. So first one is the digital modulation. So what is the digital modulation? In digital modulation, an analog carrier signal is modulated by a discrete signal. And digital modulation can be considered as digital to analog, and corresponding demodulation is analog to digital conversion. So this is the process in demodulation system and modulation system in the digital modulation technique. In digital communication, the modulating wave consists of binary data and the carrier a sinusoidal wave. In the digital communication, the modulating wave consists of the binary data in the form of digital, and the carrier signal is the sinusoidal wave, which is the high frequency signals. So there are different digital modulation techniques which are generally used in communication field. So first one here in this different diagrams of different waveforms. So first one is the baseband digital signal or message signal MD, and second one is the analog sinusoidal carrier signals. The carrier signal is the AC cos 2 pi FCT plus phi c. So this is the carrier signal which have the very high frequency. And next, third one is the ASK amplitude shift key. A message signal change the carrier amplitude in ASK system. So in this waveform diagram, the amplitude is changed with the times. And fourth one is FSK frequency shift key. In FSK, a message signal change the carrier's frequency as shown in this waveform of FSK signal, in which frequency is changed with the time. But in this FSK, the amplitude remains constant, only frequency change with time. Next one is the PSK phase shift key. In PSK, a message signal change the carrier's phase shift or phi 1t. So in the waveform diagram, the PSK signal, in this signal, the carrier phase is changed, but the amplitude and frequency is no change in PSK phase shift keys digital modulation technique. So these are the different digital modulation technique, and which is represented by the with the help of in different waveforms. First one is the amplitude shift key. In ASK, the amplitude of the signal is changed in response to information and all else kept fixed. With one is transmitted by a signal of one particular amplitude. To transmit 0, we change the amplitude keeping the frequency constant, and we can see this ASK amplitude in the given waveforms in this different waveforms. So first is the waveform is the message signal, second is the carrier signal, and third one is the modulated signals. So these waveforms show the amplitude shift key modulation technique. Next one is frequency shift key FSK. In FSK, we change the frequency in response to information. So one particular frequency for a 1 and another frequency for a 0. So in this different waveforms that represent the frequency shift modulation techniques. Next one is phase shift key. In PSK, we change the phase of the sinusoidal carrier to indicate information. Phase in this context is the starting angle at which the sinusoidal start. One phase change encodes 0 while another phase change encodes. So first to transmit 0, we shift the phase of the sinusoidal by the 180 degree or pi phase shift. We can also the changing in phase shift key or phase shift as shown in this waveform diagram. Next one is M-array modulation technique. In binary data transmission, send only one of two possible signals during each bit interval TV, and M-array data transmission send one of n possible signals during each signal interval T. In almost all applications, m equal to 2n and t equal to n TV, where as n is an integer. So each of the m signals is called a symbol. These signals are generated by changing the amplitude, phase, frequency, or combined forms of a carriers. Thus we have MASK, MPSK, MFSK, and MQAM. So next one is quadrature phase shift key QPSK. In QPSK, we can be interpreted as two independent PPSK systems and thus the same performance but twice the bandwidth efficiency. The phase of the carrier takes on one of four equally spaced values, where which value of phase is the 0, I by 2 phase, pi phase, and 3 by 2 pi phase. Pair of message bits in QAM modulation, quadrature amplitude modulation. If both the amplitude and phase are very proportional to the information signal, quadrature amplitude modulation result combination of phase shift and amplitude shifting. So the QAM modulation system as shown in this waveform diagrams. First waveform is the carrier signal waveform, and second one is the modulated resulting waveforms. And in this modulating value from 3 bits, start from 0, 0, 0, next 1, 1, 0, and 0, 0, 1, and 1, 1, 1. Next one is differential phase shift key, DPSK. For the perfect detection of phase modulated signals, the receiver need a reference signals. What if differential encoding and phase shift key are made together at the transmitter? The technique is called as a differential phase shift key. For the transmission of a symbol, one, the phase is unchanged, whereas for transmission of symbol 0, the phase of the signal is changed by the 180-degree phase shift key. In this waveform diagrams of DPSK, the phase shift is with reference to a previous bit transmitted rather than to some constant reference signals. And what is the metrics for digital modulation? So power efficiency is a measure of how much signal power should we increase to achieve a particular bit error rate BER for a given modulation scheme. Ability of modulation technique to preserve the fidelity of the digital message at low power. Designer can increase noise immunity by increased signal power. So these are some merits of the digital modulation techniques. Next one is the bandwidth efficiency. So what is the bandwidth efficiency? Ability to accommodate data within a limited bandwidth, a trade-off between data rate and pulse width, and easy to implement and cost-effective to operate. Next one is the delta modulation. Delta modulation is also a digital modulation technique. A delta modulation is an analog to digital and digital to analog signal conversion process technique used for the transfer data. Why delta modulation? Why delta modulation used? So DM or delta modulation is an analog to digital conversion technique. Delta modulation is the simplest form of differential pulse code modulation (PCM), and delta modulation used by satellite business system or SBS. So this is the application of the delta modulation used by the satellite business system. And to achieve high signal to noise ratio delta modulation, in the delta modulation, the signal to noise ratio is very high, and delta modulation can change instantly what voice signal can't change instantly. Delta modulation signal is similar than the pulse code modulation system. So DM is the similar as PCM system. So PCM is the also digital modulation technique. Here the concept of digital modulation technique. So in this waveform diagram, the delta modulation technique here. So here first wave is the original signals, and second is the integrated signals, and third one is the delta modulated signal. So there are the different signals which show the concept of the demodulation technique, and this also show the graph between amplitude versus time of the different these signals. That is the demodulation block diagram. So in demodulation block diagram, there is the digital data here in the form of 111001. That is the form of digital data. And in digital modulator, there are some networks. So first one is staircase maker, and second one is delay unit, and third one is the low pass filter. So in this demodulator, we applied the digital data to the staircase maker, and a delay unit, a signal also applied to this staircase maker, and output of this staircase maker is again applied to the low pass filter, and this low pass filter pass the low pass frequency signal, and output of this low pass filter is the analog signal, which is the output of low pass filter in the form of analog signal. So this is the modulation technique, demodulation technique. There is a simple implementation of digital modulation systems. So here is a comparator device and a integrator device and also a flip-flop device. So we applied the analog signal to the comparator, and one signal applied by the integrator output, and comparator compare these two signal, and after compare these two signal, the output of comparator feed to the D-type flip-flop, and D-type flip-flop is also a signal applied to the D-type flip-flop in the form of clock. So this is the simple implementation of delta modulation system in which comparator, integrator, and D-type flip-flop device are used. And how it work together, modulator and demodulator together works. So in this diagram, there is a part of modulator and second part of the demodulator. In first part of modulator, there is a comparator, integrator, and adaptive logic network also here. And in the demodulator parts, there is also a integrator and sample and hold circuit and low pass filter and the output signal of the low pass filter. So this is the together works modulator and demodulator. Yes, in this block diagrams. Now this is the comparison between pulse code modulation versus delta modulation system or technique. So in pulse code modulation system, a analog signal is applied to the sampling network, and the output of sampling network is applied to quantizing, and a pulse amplitude modulated signal also applied to the input of the quantizing network, and the output of quantizing network is also a quantized signals, and that signal applied again to the encoding network, and output of encoding network is the digital data or digital form of the output signals. That is the for PCM system. But in delta modulation system, the analog signal is applied to the comparator, and one signal also applied by the delay unit to the comparator, and a output of in this comparator is to feedback by the staircase maker, and also output of the this comparator is the digital data form, or that is the digital output. So these are the differentiate between PCM and DM, which can be explained with the help of the two circuit or block diagrams. And also PCM versus DM. In PCM is a method used to digitally represent sample analog signals. What delta modulation, digital to analog conversion. In PCM, signal lead encode, decode both sides. What in delta modulation, signal can modulate, demodulate. In PCM, large processes. In PCM, large process. What in DM, EG process. The PCM is the costly system, but DM is the cheap pass system. So there are some comparison between PCM versus DM here. These waveforms show the limitation of the system. So here is the slow overloaded in this waveforms. When the analog signal has a high rate of change, then digital delta modulation can fall beyond and a distorted output occurs, as we can see in this waveform. The slow overloaded systems. Sampling. What is the sampling in communication system? Sampling theorem: ideal sampling, flat top sampling, natural sampling, reconstruction of signals from samples, analyzing effects, upsampling and downsampling, discrete time processing or continuous time signals. What is the sampling theorem? In sampling theorem, a continuous time band limited signal can be represented by its samples and can be recovered from its samples. So, provided that sampling frequency omega s greater than or equal to 2 omega m, where omega m is the maximum frequency of the signal. The condition is referred as a Nyquist criteria. So, in this diagram, a continuous signal GT is sampled by the sampling network that have the frequency omega s, and that after sampling the output is the discrete time signal G naught T in the form of digital. So that is the sampling theorem concepts. What is the ideal sampling? So First we take in time domain, and second one is the in frequency domain. So in time domain, sampling results in conversion of continuous time signal into discrete time signals. And in frequency domain, sampling results in multiple translation of signal spectrum, linear combination of shifted signal spectrum at integer multiple of sampling frequency. And also we can see these in different waveform diagrams that is drawn on this slide. The reconstruction of ideal sampling reconstruction. So a digital signal is, that is the G delta T equal to 1 upon T summation of n equal to minus infinite to infinite G omega minus n omega s is applied to the low pass filter, and the output of this low pass filter is again applied to the amplifier, or then the output of this amplifier is the reconstructed signals or original analog signal, that is the GT signals. So we can reconstruct the ideal sampling signal with the help of this diagram. Next one is flat top sampling. As ideal impulse can't be generated, practical sampling pulse will exist for a duration in flat top sampling. For each samples, the value is held for a duration t, and flat top sampling may be thought of as output of a system with impulse response. So in this block diagram, that is show the flat top sampling here. Here the input is the continuous time signal GT, and then applied to the ideal sampling network of this signal. And after the sampling, this signal convert into digital signal, and also this digital signal is feed to the system with impulse response, and output of this system with its impulse response is the flat top sampling. So this is the block diagram for the flat top sampling. There are the different flat top sampling and different waveforms signals given here. Flat top sampling introduce aperture effect as percent functions. We can see in this different waveforms of this flat top sampling, and aperture effects is introduced as per sampling function. Next one is the natural sampling. In natural sampling, each sample is pulse of duration t with amplitude vary in accordance to signal value. Natural sampling may be thought of a multiplication of signal with pulse train. So in this diagram, there is a input continuous time signal GT, and this signal applied to the natural sampling network, and output of this natural sampling convert the continuous time analog signal into the digital signal in the form of natural samples. So this is the concept of the natural sampling, and there are also different waveforms that show the natural sampling process. And natural sampling introduce amplitude scaling as per sample function at every shifted version of G omega, and note the aperture effects as in flat top sampling. Next one is the upsampling and downsampling. So in downsampling, decimation, subsampling discrete signals, and upsampling introducing zero between samples to create a longer signals. So these are the upsampling and downsampling. Discrete time processing of continuous time signals. Continuous time signals can be converted into discrete time using a sampling and quantize to make it digital form. These discrete time signal can be processed using computer-based discrete time systems, and output can be reconstructed as continuous time signals. So in this diagram, there is a analog signal that is applied to the analog to digital converter or sampling quantization network, and after the sampling or quantization, the output of this network is again applied to the discrete time signal, and output of this discrete time signal will again to the D2A converter or reconstruction in this D2A converter. So output will be analog signal here, because digital signal converted into analog signal with the help of digital to analog converters here. So this is the diagram of discrete time processing of continuous time signals, in which a analog signal convert into the quantization form, and again in discrete time system converted into the digital form, and by the D2A converter signal is reconstructed into the analog signal forms. These are some reference books for this topics. First one is Analog Communication by Bhatt and Rao, and second is the Digital Communication by T. and Shingles. Here some multi-choice questions. These are very important and very interesting for understand the concept of this topics. So we will discuss these questions one by one. Question first: what are the primary features of a transmitters? So option A, lower clock speeds. Option B, lower transmitting power. Option C, higher clock speeds. Option D, none of these. So for primary feature of transmitter, so there is a correct option of correct answer is D, none of these, because for transmitter, lower clock speed is not required, lower transmitting power. So this option is incorrect or wrong. And higher clock speed, this is also wrong. And none of these. So for the primary feature of transmitter is none of these here. So correct answer is D. Next, the window gives a number of option A white, option B frames, option C both option A and B, and option D none of these. So here correct answer is option C. The window gives a number of bytes as well as frames. So correct answer here option C. Next question. Which of the given device does the data compression? Option A, switches. Option B, circuit breakers. Option C, microcontroller. And option D, source encoder. So here, which of the given device does the data compression? So the function of data compression is the option D is correct answer, source encoder, because source encoder function is that this device does the data compression. So here correct option is D, source encoder. Next, space loss occurs due to the decrease in phase shift, option A, option B, momentum, option C, electric field strength, and option D is the power. So here in this question, space loss occurs due to a decrease in electric field strength. So here correct option is electric field strength, because space loss occur due to decrease in electric field strength. If we decrease the electric field strength, so space losses occur. So here correct option is the option C, electric field strength. In next question, the power spectral density PSD of a signal is option A, even, negative and complex, option B, odd, complex and positive, option C, real, odd and negative, option D, real, even and non-negative. So for the PSD of any signal is the option C, option D is correct. PSD of signal is real, even and non-negative. So here correct option is the option D. And next, a modulator is a device used to, so what is the use of modulator? So option first, A, differentiate two frequencies. Option B, amplify two radio frequency signal. Option C, impress the information onto a radio frequency carrier. Option D, reduce the modulating power requirement. So here correct answer is option D. The modulator is a device that is used to reduce the modulating power required. So here correct answer is the option D. Next question, a balance modulator is used in the generation of which of the following signals? Balance modulator is used in the generation of which of the following signals? Option A, frequency modulation signals. Option B, DSB-SC signals. Option C, ISI signals. Option D, SSB-SC signals. Option here, correct answer is option B, because in valence modulator is used in the generation of double sideband suppressed carrier signals. So the function of here of a valence modulator is used to in the generation of the double sideband suppressed carrier signal. So here correct option is the option B, double sideband suppressed carrier. In next question, which of the given modulator is an indirect way of generating of FM? So, which of the modulator is an indirect way of generating frequency modulation? So, option A here, inductance field effect transistor modulator. Option B, Armstrong modulator. Option C, reactance tube modulators. Option D, Zener diode modulators. And option B here is the correct answer, because the modulator is a indirect way of generation of FM is a Armstrong modulator. So the Armstrong modulator used as a indirect way of generating the frequency modulation. In next question, in a FM modulation or frequency modulation, when the modulation index increase, the transmitted power. So in this case, if we increase the modulation index, so what effect on the transmitted power? So option A, transmitted power will be half. Option B, it will be decreased. Option C, it will be doubled. Option D, it will be unchanged. So here, correct answer is the option D, because the transmitted power not depend on the modulation index. So we, if increase the modulation index, there is no change in transmitted power, or we can say that the transmitted power not depend on the modulation index of the FM modulation system. Next question and last question, in the phase modulation, phase deviation is proportional, or modulation index is proportional to which of the following? In phase modulation, the phase deviation is proportional to which of the following? Option A, the wavelength of the message signal. Option B, message signal. Option C, the amplitude of the message signal. Option D, the phase shift of the message signal. So in this question, correct answer is B, message signal, because in phase modulation, the phase deviation or modulation index in phase modulation or PM modulation is proportional to the message signal. So here correct answer is the option B. So thank you very much.